Okay, now let's look at some basic equations involving electricity. So here's a very simple circuit: a bulb connected to a battery. When you connect a bulb to a battery, what you have is a current that flows through like that. What is really happening is electrons flow in this direction, and that what this device does is converts electrical energy into light. Okay, so what this equation is telling you is V is the voltage of the battery, the current flowing through the device is I, R is the resistance of the bulb. Okay, so higher the resistance, lower the current. The power supplied to this device is the voltage across it times the current flowing through it, or the terminal voltage of the battery times the current flowing through it. That's the power. So if this was a 100-watt bulb, now I'm simplifying this, so 100 watts was being supplied to it. Okay, 100 joules per second is being supplied to it. Here are two other formulas for power. Power can be also calculated as I square the current flowing through the device square times the resistance of the device, or V square over R. Okay, just some basic equations. Electromagnetic energy. So you can go outside in the sunshine and you'll feel the warmth. So you know that sunlight carries energy, and all electromagnetic radiations come in packets called photons, little packets called photons. So here's a little picture. Oops. So here's a cartoon picture of a photon, and the energy of this photon is h, something called the Planck's constant, times the frequency of light. Okay, and the wavelength of light is given by the speed of light divided by the frequency. Uh, the speed of light is frequency times the wavelength. Okay. Anyway, so well, these formulas are just something that we are introducing. And if you take a physics course, you'll get a better understanding of all of them. So let's look at all the different kinds of electromagnetic radiation out there. So gamma rays, electromagnetic radiation, X-rays, UV light, visible light. So this is the part of the electromagnetic spectrum that our eyes are sensitive to. Okay, so our eyes are sensitive to a very tiny portion of the electromagnetic radiation of the electromagnetic spectrum. Infrared rays, radar, FM, TV, shortwave, AM, they're all electromagnetic rays, radiation. The only difference is their frequencies are different. So as you go in this direction, the frequency increases. And you saw that the higher the frequency, greater the energy of the photon. Okay? So if you go in this direction, they're more and more energetic. So like this thing says, high energy, low energy. So red light is low energy light, violet light is high energy light. Okay, so like I said, electromagnetic radiation comes in little packets called photons, and the energy of the photon is h, Planck's constant, times the frequency of the radiation. All right.